This video is all about the moles equation. Now this equation is probably the most important in GCSE chemistry. It is absolutely essential that you learn this. It is as follows. Moles equals mass divided by the relative atomic mass. Okay, or the mass of one mole of an atom, or the mass of one mole of a formula. Okay, I write a subscript R like this because writing relative atomic mass out is quite a mouthful. Okay, relative atomic mass. But you can write relative atomic mass out if you want. But if you know that the abbreviation AR is relative atomic mass, then you may stick with that. Okay, so that calculates the number of moles. We can use that to calculate the number of moles of an element. Okay, there's about 100 elements on the periodic table. And if we have the atomic mass and the mass of the sample, then we can work out exactly how many moles we have. Now, it is exactly the same formula if we're working out the mass of a compound. We just need to know the formula mass of the compound. Okay, so moles equals mass divided by formula mass. I'm just going to use the abbreviation MR for formula mass. So MR equals relative formula mass. Okay, so essentially this equation is moles equals mass divided by the mass of one mole, whether it's the mass of one mole of an atom or the mass of one mole of a molecule, say. So these are the equations we're going to use here. Okay, got some very straightforward questions down here if you know, and if you know how to do them, of course they're straightforward. If you don't, they're not, but we can, with practice, make them straightforward. So for each and every one of these, remember it is absolutely essential, absolutely crucial that we learn this equation. Okay, so for each of these, we're going to write out this formula. And when I check your books in lesson, I always insist the formulas are written, because every time we write it out, we learn it a little bit better. Okay, and that's the aim of the game, is to learn this stuff in a smart way, not a hard way, so we don't have to revise too much come the exam time, because we'll simply know it. So it's really important we write out these formula every time we do one of these questions. So this is 24 grams of carbon. Carbon's an element, so we're going to do moles equals mass divided by relative atomic mass. We know the mass here is a mass because it has a unit at the end of it. Mass always has a unit at the end of it. So it's 24, whereas atomic mass, these are atomic mass units, they don't really have a unit as such in the way that mass has a unit of grams or tons or whatever else. So there's no unit on these. So that's 12. 24 divided by 12 is 2 moles. So if we have 24 grams of carbon, we have 2 moles. And for each and every one of these, we want to work out exactly how many moles we have. So moles equals mass divided by atomic mass. Again, it's atomic mass because this time it's potassium. 19.5 grams, we know it's a mass because it's got a unit at the end of it. 19.5 divided by 39 equals 0.5 moles that time. Okay, 108 grams of water. All right, so not an element this time, this is a compound. We've got a molecule of water here, so we're going to use moles equals mass divided by formula mass. This time, exactly the same equation. Okay, but this one there's two stages really. The mass is 108 grams, that's easy enough, but we need to work out the formula mass of water. To do that, we need to be able to count the atoms in water. Now, we've done this in a couple of videos so far, so if you're not sure about counting atoms, I'll quickly run through it here, but go back and watch Balancing Equations video 1, that's all about counting atoms. Okay, so water is H2O, so that's H plus H plus O. Okay, there's a 2 after the hydrogen, which means there's 2 hydrogens present. There's no number after the oxygen, and if there's no number present, there's always a 1. Okay, because we bothered to write O, so there must be at least one of them present. So hydrogen has a mass of 1, so that's 1 plus 1. Oxygen has a mass of 16. So that's 1 plus 1 plus 16 equals 18. So to do this with a formula mass, we first have to work out the formula mass from the formula and the atomic masses. So mass is 108 divided by 18. Get my best guesses, that's 6, but we'll quickly put in a calculator just to double check that. So we've got 108 divided by 18 equals, 6 moles. I always like having a little guesstimate in my head to start with, because it's so easy to put numbers in the calculator incorrectly. So if that came out something wildly different to 6, I would go and check it again, basically. Right, 4.5625 grams of HCl, hydrogen chloride. Right, so the formula here, H, no number after the H, so there's one of them. Capital C, and followed by a lowercase l, so that L goes with the C, that therefore is chlorine. It's not carbon, it's chlorine. So we've got one hydrogen, there's no number after the chlorine, there's one there as well. So we've got one hydrogen, one chlorine. So we're going to write it out again, moles equals mass divided by formula mass. The mass is 4.5625. We've got one hydrogen in hydrogen chloride and one chlorine, so that's going to be 1 plus 35.5. Let's put this in brackets because it's important we work that out first. So let's write that out again now with the bottom worked out. 4.5625 divided by 36.5, because 1 plus 35.5 is 36.5. So what's that going to be? It's obviously a fraction, isn't it? So it's around about 0.1, 0.2ish. 0.2ish maybe, who knows? Let's put it in there and have a quick look. 4.5625 divided by 36.5 equals 1/8. 0.125. I said between 0.1 and 0.2, didn't I? So that sits with my guesstimate quite nicely. Okay. All right. And the last one over here, 1,428 grams. That's the mass, because it's got a unit after it, of Al2O3 aluminium oxide. All right, so we've got Al2, so that's 2 aluminiums, and O3, 3 oxygens. I think it's important we work that out first. So you can write it out in quite a long-winded way. And if you're a bit unsure with your maths or your chemistry, then why not do it like this? Maybe it takes a tiny bit longer, maybe it doesn't look quite so neat mathematically, but if we get the right answer, that's what counts. So aluminium is 27, so that's 2 aluminiums there, so it's 27 plus 27 plus 3 oxygens, O3. Oxygen is 16, so that's going to be 16 plus 16 plus 16. 27 and 27 is 54. 3 16s, 48. So that's going to be 102, isn't it? 48. Let's just check that. 54 and 48. 102. Let's put that in the calculator because my mental arithmetic has a habit of letting me down occasionally. So it's 54 plus 48. 102. So our formula mass of aluminium oxide is 102. So moles equals mass divided by formula mass. Mass 1428. 1428 divided by 102. My best guess is that it's 14, but we'll quickly put it in the calculator. And you can have a crack at that at home as well. 1428 divided by 102. 14 moles. Okay. Put the moles equation into a formula triangle. Right, so as well as knowing this most important equation in the whole GCSE chemistry, we have to be able to rearrange it. Okay, to rearrange equations, I do think formula triangles are brilliant. I got through my entire formal education with these things. Every formula triangle with a when a formula has a divide or a multiply in it, it looks exactly the same as this. They all have a divide and a multiply. Okay, to put this into there, into that formula triangle, the only thing we have to do is ask ourselves 2 questions. Does this formula here have a divide or a multiply in it? Answer, divide. Okay, happy with that? It's got a divide in it. That's the first question we have to ask ourselves. Second question, what's on top of the divide? Mass is on top of the divide. Down here, there's the divide, mass goes on top of it. Which means the other 2, moles and MR, have to go on the bottom. Moles and MR. So these formula triangles are great if we want to say, if the question is, what mass of something is there, put your finger over mass, and it's moles times mR. If the question is how many moles are there, put your finger over moles, it's mass divided by mR. Okay, so those formula triangles absolutely essential, because on the next page now, we are going to calculate the mass of. Okay, so it's exactly the same as what we've been doing. Okay, remember this formula triangle a moment ago? It had mass on the top, moles times formula mass. Okay, so it's crucial that we learn this, and or that we can rearrange instantaneously. So calculate the mass. Finger over mass. Mass equals moles times mR. Let's write that out there. Mass equals moles times mR. Okay. Now you'll notice the sharp amongst you now will notice that I've written formula mass there, and this is actually copper, so we really should write atomic mass there for correctness sakes. You're not going to be marked down on a GCSE exam for that, but I suppose let's, for correctness sake, change that to formula mass. Relative formula mass and relative atomic mass are completely interchangeable in this, depending on whether we're doing with an element or a compound. Right, moles, 2.5, 2.5, copper, 63.5, 63.5, 2.5, 63.5 is about 150. So in my head guess, quickly do this now. So 2.5 times 63.5 equals, I said about 150, 158.75. 158.75. Okay, now this is a mass, so now it's important we put a unit at the end of it, grams. Okay, these always work out in grams. If we've given a number of moles and we're working on formula masses or atomic masses, the unit is grams at the end. Not going to do the second one, you can do that on your own. Let's quickly do this one here, and then I'll leave you to do the last one on its own as well. So it wants mass, calculate mass, so it's important we write out mass equals moles times formula mass. It's definitely a formula mass this time, because there's a formula. Right, so C2H5OH, let's work out the formula mass first. So C2, carbon plus carbon, H5 plus hydrogen plus hydrogen plus hydrogen plus hydrogen plus hydrogen, 1, 2, 3, 4, 5. O plus oxygen, and we've got another hydrogen at the end there, plus hydrogen. Now, as I said, that's quite a long-winded way to write it out. You can do it far, far quicker, but I said if you're a bit nervous with your chemistry or your maths, it doesn't hurt doing that way. Carbon's got an atomic mass of 12, so I put 12 beneath each carbon. Hydrogen's got an atomic mass of 1, so we need to put 1 underneath each hydrogen. Oxygen 16, and hydrogen 1 at the end there. So 12 and 12 is 24, 25, 26, 27, 28, 29. That's going to be 39, 45, and that one there's 46. 46 is the formula mass. So we've got a formula mass of 46. Okay, moles is 5. 5 times 40 is going to be 200, so that's going to be 5 times 6 is 30, so that's going to be 230. Let's quickly put it into the calculator. To check we're happy with that. 5 times 46 equals 230. So I'm more than happy with that answer. 230, and of course it is grams. Okay, you can have a go at the rest of those on your own, and that's an introduction to this basic and most important moles formula. You must learn that moles formula.